Hello dear students, welcome back to your math classes. How are you all? I hope you all are healthy and great. So students, I'm your mathematics educator again here with a new chapter and a new concept. And today we have chapter number 6, which is algebraic expressions. So when we deal with unknown values which is not already calculated, or we cannot easily examine that what are the values we have, then we consider algebraic expressions. For example, your formula for rectangle is length into breadth. So you don't know what is your length and breadth. You just examine that whatever it is, you just have to multiply them together. So at that moment we are using algebraic expressions. Let's understand it in detail. First of all, in this previous class you have learned some basic concepts of algebra. You have learned about literals, their addition, subtraction, multiplication and division, constant variables, algebraic expressions and their terms. In this chapter you shall learn about more about algebraic expressions, their types, factors and coefficients of terms, also their addition and subtraction. So before starting this chapter, let's take a recapitulation. First of all, what we understand by literals. The letters which are used to represent numbers are called literals, numbers or simply literals. So algebraic expressions means when we have alphabets in our mathematical world. So the alphabets we are using, that is called your literals. Next we have variables. When a letter is used to stand for various numbers, it is called a variable. If m represents a whole number, then m is a variable as it takes value 0, 1, 2, 3. It means that in your algebraic expressions, the numbers you are using, that is your variables. Constant, if a letter represents a fixed numerical value, then it's called constant. Constant means a fixed value. For example, if t represents a number of months in a year, then t is a constant. It has a fixed value which is 12. Now we have algebraic expression. An algebraic expression is a combination of constants and variables connected by the symbols of basic operations of addition, subtraction, multiplication and division. And these are the examples we have of algebraic expression. Algebraic expressions means that when we are using our numbers and alphabets together with the help of our operations, right? And we already know that alphabets means literals and numbers means variables. So we are connecting them together with the help of our operation. That is why I call it algebraic expression. In algebraic expressions, we are deal with our terms. So parts of the algebraic expression separated by the symbol plus are called terms and called terms of an algebraic expression. For example, in this expression 5x plus 6y square, the terms are 5x and 6y square. In this expression 10 minus 8p plus q, the terms are 10 minus 8p and q. So a term can be a constant, a variable or a combination and or variables using operations, multiplication and division. So I hope so students this recapitulation part help you to remember your previous concept. Now we are going to learn a new concept which is types of algebraic expression. So algebraic expressions are categorized according to the number of terms they contain as follows. Monomial. So if we have only one term, a monomial is an algebraic expression which contains only one term and all the variables in the term are raised to a whole number power. So 5x minus 3x square, 2 by 7 pq are all monomials. So you just have to take a hint from their name. Monomial means single term. Binomial means two terms. Trinomial means three terms. Polynomial means more than three terms. So an algebraic expression in which all the variables occurs with exponents as 0, 1, 2, 3 whole numbers only, it's called a polynomial. It may contain one or more term. Okay, so by just seeing their name, you can easily identify in which you have one term, two term, three term and more than three term. So monomial only one term. Binomial where we have two terms. Trinomial three terms. Okay students. Now we have factors and coefficients. Now we discuss the components that constitutes a term of an algebraic expression. Factors. A term is an algebraic expression is a product of two or more literals and or numerals. Each of these literals are numerals. It's called a factor of that term. For example, in this 3xy. What are the factors we have for 3xy? 3x and y, because we are multiplying them together each other, right? 3 multiplied by x multiplied by y. That is why the product of these three, we have 3xy. Okay. Now in this minus 7a square means minus 7 multiplied by a, that is why this is minus 7a square. Now the literal factors of a term are written in a manner that they cannot be further split as product of two literals. For example, factor of 6ab are 6a and b and not 6 and ab. Okay. While writing factors, the numerical factor 1 is not written as a separate factor. For example, okay, wait. So you just have to consider that whenever you have to writing factors, the numerical factor 1, it's not written as a separate form. Okay. Now we have constant term. A term of an expression having no literal factor is called a constant term. For example, in this expression 2x raised to the power of 2 plus 5, the constant term is 5. So in the 5, we don't have any literal. Constant term means when we are not using any alphabet with it. Okay. Now we have coefficient. In a term of an algebraic expression, any of the factors, product of factors with the sign of the term, it's called the coefficient of their product of the remaining factors. For example, in the term 6xy, 6 is the coefficient of xy, x is the coefficient of 6y. In this case, what you have to do, for example, you have 6xy. So when we are talking about the coefficient of 6, so we have to cancel out 6 and what we left with xy. It means the coefficient of 6 is xy. For example, now we are discussing with the coefficient of x. So it means we have to cancel out 6 and we left with 6y. So whichever coefficient we want to know, we just have to cancel it out, and the left numeral literals we left with, that is your coefficient for that particular term. Now, in the particular, the numerical factor of a term is said to be coefficient of the term. For example, in the term minus 2x square minus 2, which is the coefficient of x square, it's called coefficient of the term. In the term 7ab, 7 is the coefficient term of ab. Okay. Now we have example number 1. Identify the monomials, binomials and trinomials from the following algebraic expressions. 1, 2. Okay. Monomials are b. Okay. B, E, that's it. Binomial when we have 2, 1, 2, 1, 2. So A and D are binomials and trinomials are C and F. Write the coefficient of x in. So you just have to cancel out x and you left with minus 3 and y. So your coefficient is minus 3y. A square. So you have to cancel out a square. You left with 7b square c square. So in same way you have to write and understood it. Okay. Now write the coefficient of each term of the algebraic expression 7x square minus 5y square plus xy and minus x. So the given algebraic expression is this. The numerical coefficient or the coefficient of this term is 7, minus 5, 1 and minus 1 respectively. Okay. Now identify the constant term in the following. 8 is the constant term in this term and 3 minus 3 is the constant term. Now we have like and unlike terms. So when we have same alphabets, okay, that is your with same power as well, that is your like terms. And when you have different alphabet, that is your unlike terms. For example, the terms having the same literal factors are called like or similar terms. The terms having different literal factors are called unlike or dissimilar terms. xy, xy, like terms. A square, b square, a square, b square, like terms. A, b square and ab. So alphabets are same but their power are different. For example, a, b square, and in this case we don't have any square. So it means these are unlike terms. 8x cube minus 8x cube and 7y cube. So x and y both are different. That is why they are unlike terms. Now we have our example. Identify the like terms among each of the following groups of terms. So minus 2x square and minus 3x square both are like terms. 5x square and minus 9y square are like terms. So you just have to examine the same alphabets with same power. So that is all like terms. Okay. Now we have to identify the like terms in the algebraic expressions. Again, the same process we have to do here. So 3 by 4a square and 7a square are the like terms. C square and minus 4c square are the like terms. Now we move forward to our exercise, which is 6.1. Express each of the following as an algebraic expression. Product of x and sum of y and z. So product of x and sum of y and z. Product means multiplication and sum means we have to add something. Okay. Next, sum of square A and B. So sum of square, it means A plus B whole square. Okay. So in same way, you have to represent your statements into algebraic expressions. Now we have question number 2. Identify monomials, binomials and trinomials from the following. 1, 2, it means bi. 1, 2, 3, it means tri. Only one, it means mono. So in same way, you have to represent your numbers among mono, bio and trinomials. Now we have write all the terms in each of the following algebraic expressions. So in this 4x plus 5y, we have two terms, 4x and 5y. In this case, what you just have to do, you just have to remove your operation sign and then you have your terms. Okay. Next, 2ab minus bc plus 9. So in this, I have three terms, 2ab, bc minus bc and 9. So in same way, you have to represent the terms in the following expressions. So now we have question number 4. Write the coefficient of x in the following terms. So in what we understand in our above section, when we have to take any coefficient of that given number, so we just have to remove that. So if I cancel out x, it means in this I have only 7, a coefficient of x. In this a, in this minus 5y square. So in same way, you have to find out the coefficient of rest of the two parts you have in question number 4. Now question number 5, identify the constant term in each of the following expressions. So this is your constant term, this 8. So in same way, you have to identify the constant term in rest of the parts you have. Question number 6, write the numerical coefficient of terms except the constant term. Write the numerical coefficient of terms except the constant term in each of the following algebraic expressions. So in this 4x square minus 3x plus 7. So we don't need to write the constant term. So cancel out. Now we have two terms, 4x square and minus 3x. In this, I have numerical value only 4 and in this, I have minus 3 only. So in same way, you just have to write down the numerical value. So in this case, you have only minus 3, this 5, minus 8. So in same way, you have to find out the numerical coefficient for rest of the parts you have in question number 6. Now question number 7, write the coefficient of a. So I have to cancel out a. It means 3b square is the coefficient of a. Y. So I have to cancel out y. I left with minus 8xz. So this is the coefficient of y. Now we have question number 8. Identify like terms among the following. So 2x cube, 5, okay, 2x cube and 7x cube. Then minus 5x square and 5x square and y square. Minus 9x square and y square. Then x square and x square. Minus 4x y square and x y square. That's it. These are the like terms you have. 6x square y, it's not a like term. Here we have. So these are the like terms you have. In same way, you have to identify in part B. Now we move forward to our next concept, which is addition and subtraction of algebraic expression. An algebraic expression consists of terms, some of which may be like and some unlike. We can simplify an algebraic expression by combining or collecting like terms. Unlike terms cannot be combined and are written as such. Combining like terms explain the process of addition of like terms. The term addition suffices are subtraction of terms is same as adding a term whose numerical coefficient is additive inverse of numerical coefficient of the term to be subtracted. It means, in short, we can understand this, that we can do our operations only on your like terms. Okay, we cannot apply our subtraction and addition over the unlike terms. So understood it. Now combining like terms, for example, when two or more like terms are combined, we get a term with same natural factors as the given terms and whose numerical coefficient is the sum of the numerical coefficient of the given terms. For example, I have 2a minus 5a square plus 6a plus a square. So in this case, what we understand that 2a and 6a both are same coefficient, same, both are like terms, right? So we can add them together. 2 plus 6 is 8 and this 8a is your answer. Minus 5a square and plus a square means both are like terms. We have to subtract it. Minus 5 plus 1 is minus 4a square. So your answer is 8a minus 4a square. You always have to operate your addition and subtraction over the like terms only. Okay. Now simplify 2x minus 7 minus x plus 6x 5. So in this case, we can operate with these two. Wait, this also. And so 2x plus 6x is 8x. 8x minus x is 7x. 5 plus minus 7 is minus 2. So your answer is 7x minus 2. I hope so, student, this is clear to you. Next, we have adding algebraic expression. The sum of two algebraic expression can be found by writing the two expression with a plus sign between them and then combine like terms. For example, I have 2x minus 9 and 4x plus 1. So I put a plus sign between them and simply operate with the addition. So 2x plus 4x is 2 plus 4 is 6x and plus 1 and minus 9. So we have to subtract 6x minus 8 is your answer. You may find use of columns helpful in collecting like terms. To do so, write the algebraic expression one below to the other, listing like terms under the another and leaving spaces for missing terms. The combine the terms are columns. So in this way, you can write this as well. 5x square below the minus 2x square. You have to write 5x square below 2x square. Minus x, we don't have any minus x. So you have to left the space for this and then 2 and minus 10. So this is your final answer. So you have your choice which one you find you easy and simpler for you. You can opt that and solve your algebraic expression accordingly. Now add 2a minus b plus 4, 3a plus 5b minus 8. So 2a and 3a is 5a, 5b and minus b is 4b, 8 minus 4 is minus 4. So this is your answer. So in same way, you have to solve these questions. Now we move forward with our subtracting algebraic expression. As subtraction is inverse of addition, to subtract an algebraic expression from another, change the sign of each term of the expression to be subtracted and then add it to the other expression. Just like in addition, you can write the algebraic expression in a horizontal row or in columns. While using columns, mark the change sign of each term of the expression to be subtracted below the original sign of each term. The examples given below will clarify the procedure for you. So here we have 2x minus 4y and 6x plus y, 5y. So in this case, you have to change the sign of your second term. 6x plus 5y, you have to add a minus sign, 2x minus 4y. So it will be further converted 6x plus 5y plus 2x will be converted minus 2xy and minus 4y will be converted into plus 4y. Now you can simply solve your question. 6x and minus 2x is 4x. 5y plus 4y is 9y. So this is your final answer. Or you can write it like this: 6x plus 5y, 2x minus 4y, and the opposite of the number. What is happening here, that when we have minus sign here in this bracket, we have to multiply our minus sign with the number. So minus multiplied by plus 2x is converted into minus 2x, and when I multiply minus with minus 4y, so minus minus is plus, so it will be converted into plus 4y. So you just have to consider and keep in your mind that when you have to subtract your term, so the second term you have, okay, you have to take the opposite of that side. Plus opposite is minus and minus opposite is plus. If you consider that and do in that way, so your question is easy for you. Now from the sum of 2x minus y plus 3z and 5x plus 6y minus z, subtract 4x minus 8y 2z. So first of all, you have to add these two terms together, 5x, 2x. Okay, so just you can write it like this also: 7x minus 4x, 5y plus 8y plus 2z plus 2z. The final answer is 3x plus 13y plus 4z. Or when we write in column way, 2x minus y plus 3z, 5x plus 6y minus z, and 4x minus 8y minus 2z, and in this case we have to take opposite of it. So 3z, 2z, 5z minus z is 4z, 5, wait, minus minus plus, so 9y minus 6y is 13y, and 2x, 5x, 4x, 2 plus 5 is 7, 7 minus 4 is 3. So this is your answer. Okay, what should be added to this to obtain this? So we have to subtract this from this to find out, and while we subtracting it, so what we get, 3x cube plus 6y cube minus 4x square y square plus 1. Okay, now we move forward to our exercise 6.2. Add the following. So this is very simple. 4x plus 6x, 4x minus 6. It means minus 2x. You just have to keep in your mind that it means you have 6 times x and 4 times x. And somebody asks you you have to subtract it because minus 6 times you have x and plus 4 times you have x. So for example, that way you have to solve this question. Your algebraic expression operate with addition and subtraction over there. For example, if you have 10 toffees and 4 are taken by your brother, how many are left with it? So in that way you have to solve it. So make a story like this in your mind and then try to solve it. Then this algebraic expression operation finds you easy. Okay, now 7y square and minus 7 square. So in this case what we do here, you have 7 chocolates and your brother take all 7 chocolates. So how many left with you? 0. That's it. Okay, student. So by making stories like that without considering that, oh my god, that is very difficult for me because in this I have alphabets, just make a story and then try to solve it. Then it will become easier for you. Now 5a from 12a. So it means you have 12a minus 5a. It means you have 12 chocolates and your brother taken 5 chocolates from that. So how many left with you? So it means 12 minus 5 is 7. So 7a. Okay. So in same way you have to solve it. Now minus 6xy and 7xy. So only xy is left. Okay. Now we have question number 3. Add the following expressions. 3x minus 2y, 4x plus 6y. Minus plus minus, so we left with 4y plus 3x plus 4, 7x. Okay, next question we have minus 9a cube plus 2a square plus a, then 9a plus a cube plus 2a square. Next 2a minus 9a square and minus a cube. So this minus plus are cancel out with each other. Okay. Oh, sorry. We have to start here. 9a plus 2 is 11. 11 plus 12. So total we have 12a plus 9 minus 2 to 4a square, and we have to subtract it from 9a square. So you left with 5a square with minus sign. Now minus and positive a cube are cancel out with each other. So we have left with 9a cube. So in that way you have to solve these questions. It's totally up to you. You want to solve it in horizontal way, you can opt that to method as well, or if you want to write in column wise, so you can do that as well. Now we have question number 4, where we have to subtract 4x square minus y square from 10x square plus 3y square. Okay, so 4x square minus y square. We have to take the opposite of second term, right? So here we have minus, plus and plus is plus, so 4y square total, minus and plus is minus, so 10 minus 4 is 6. So your answer is 6x square. Okay, next take one more question. Let's take one more question, this one. P square minus plus 3p, and we have to subtract p square minus 2p, and here we have plus 1. Now the sign opposite plus, minus and minus. So plus 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 5p plus minus cancel out with each other. Now 1. So minus 1. So this is your answer, 5p minus 1. So in same way you have to do rest of the parts we have in question number 4. Now we have next question. What should be added to this to get this? So we have to subtract plus, minus, plus, minus. Plus and minus is minus, so 2. Plus and minus is minus, so minus 4x plus then minus 2x square. So this should be added to this to get this. Okay. Next, what should be subtracted from this to get this? So it's the same procedure you have to do here. Just you have to change your sign. In this case, I am subtracting. In this case, you have to take addition. On subtracting this from so on subtracting 1 minus 2x minus 3y from an algebraic expression, we get this. Find the algebraic expression. The same you have to do. You just have to subtract this value from that algebraic expression and you will get your answer. Now we move forward, evaluating algebraic expressions. Since an algebraic expression is a combination of constants and variables, its values vary with the values its variables take on. When a variable is replaced by a number, we say that we are substituting for the variables. Evaluating an algebraic expression for a given values of the variables involved means to substitute the given values of the variables in the algebraic expression and then simplify the numerical expression thus obtained. So it means when we have a particular value for our variables and we have to put into that and we have to find out the exact value. Similarly, as we do in our measurements. For example, I have a formula which is for area of rectangle, length into breadth. So I don't know what is my length and breadth. In that case, if somebody tell me that your length is equal to 3 and your breadth is equal to 4, so what we have to do, I have to put this value into the formula, and 3 multiplied by 4, it's equal to 12 centimeter square. This is my area of that rectangle. So the same procedure you have to do here. This is your expression 3x minus 2 and you have to put these values into that. So if I have 3x minus 2, 3x minus 2, it means 3 multiplied by 5, where I have x, I have to take that, and minus 5. So 15 minus 2 is 13. You just have to do 3x minus 2. Next term, for example, I'll take C part, half. So write 3 first. In the place of x, 3 is multiply with x. So you have to take multiply sign and put the value of half and minus 2. So your answer is 3 by 2 minus 2. This is your question, and when you solve it, so you will get your answer minus 1 by 2. So in such a way, you have to solve these expressions. Now if x is equal to minus 1 and y is equal to 2, then value is. So now you have two different values for x and y. You have to put both the values into your algebraic expression. 3 multiplied by x means 3 multiplied by minus 1. Plus y means plus 2 and plus 1. So you have your answer, which is 0. So in same way we have to solve now algebraic expression by putting the values into this. Now we have our exercise 6.3. A is equal to 3, which means 2a minus 7. 2 multiplied by 3 minus 7. 2 3s are 6. Minus 7 is equal to minus 1. Next we take this question. 4 minus 3a plus a square plus a cube. So 4 minus 3 multiplied by 3 plus a square means 3 square plus 3 cube means 3 cube. 4 minus 3, 9 plus 9 plus 27. 9 plus and minus 9 is cancel out with each other. 27 plus 4 is 31. So your answer is 31. So in same way you have to solve it. You have to solve rest of the parts you have in question number 1. Now question number 2, you have values x is equal to minus 2 and y is equal to minus 3. So x square plus x square minus 2xy plus y square. So minus 2 square minus 2 and minus 3 plus minus 3 square. Minus 2, so plus 4 2, 3, 6. 6 multiplied by 2 minus 12. 4 minus 12 plus 9. 4 and minus 12. 4 plus 9 is 13 and minus 12 is equal to 1. So this is your answer. So in same way, you just have to put the values into your algebraic expressions and you will get your answer. In question number 3, you have to again proceed with the same thing. Your expression is a square plus b square minus c square. So 1 square plus minus 3 square minus 2 square. 1 plus 9 plus 4. 1, 9 and 4, 13. 13 plus 1 is 14. So 14 is your final answer. So in same way, you have to put the values into your algebraic expression and further you have to calculate. And this is the end of your chapter, students. And these are the things you have to keep in your mind while you solving this chapter. I hope so, students, this chapter is clear to you and you understood it very well. Now I'm going to meet you in your next class. Till that, bye-bye. Have a good day.